Okay, we're reviewing Chapter 6. Chapter 6, solving linear equations and inequalities. In the first section, we talked about graphing to find the solution. So when we graph, if it has one solution, say 3, 6, one solution, we call that consistent. And independent, it's 1. So it's by itself. If it never crosses, so it's parallel, that means there's no solution and it is inconsistent. As long as there is a solution, sometimes there are infinite solutions, then it is consistent. Infinite solutions would mean the two equations are actually the exact same line on the graph. So if it has many solutions, it is dependent, as if it depends on all the others. So let's look at some examples of equations that are graphed on the same coordinate plane and see where they cross, if they do. Taking a look at this one, these are parallel lines, and they never cross, so they are inconsistent. The answer is no solution, inconsistent. And you can tell that this would be parallel because they have the same slope but different y-intercepts. Here we have two equations graphed, and they meet at one point, which is 2, -1. If they meet at one point, that means they're consistent. If they have any solution, they're consistent. If it's only one, it's independent. To graph that, remember, we want to put that into slope-intercept form. Here we have two equations, and let's go ahead and put the second one into slope-intercept form. Subtract 8x from both sides, divide by -4. And you take a look and see that these are the exact same line. So if it is the exact same line, that means it has infinite solutions. If it has any solution at all, remember, it is consistent. And if it has many, that means it is dependent, depending on all the others. The next section, we talked about substitution to find the solution to systems of equations. You want to get one variable by itself. In this case, y is already by itself. We're going to substitute in y, in this equation, the 2x, what it equals. So 3x plus 4 times 2x equals 11. Do distributive there. Collect like terms. Divide. X is 1. Going back to one of the originals, I'm going to use the top one, we put in 1 for x to find y. So the answer is 1, 2. We can go back and check that, putting in 2 for y and 1 for x. Yep, 2 equals 2. Putting in 1 for x here, and 2 for y. Yes, 3 plus 8 is 11. So yes, you should always check them to make sure you have the correct solution. And next we talked about elimination. Elimination to find the solution to systems of equations. So here we have two equations. I want to write them on top of each other. We're going to add or subtract them to get rid of one of the equations. So we look for a variable that has a coefficient with it that is the same. These both have -1 as the coefficient. If they have the same sign, in this case it's negative, then we subtract. If they have opposite signs, we add. 5m minus 7m is -2m. Negative p minus negative p means plus a positive. That is 0. We got rid of the p's. 7 minus 11 is -4. Divide by -2, and m equals 2. Go back and substitute 2 in for m in one of the equations. I'm going to use the top to find p. We don't want negative, we want positive, so switch the signs. So we got 2, 3. Going back to check that into the originals, 5 times 2 minus 3, that's 10 minus 3, that does equal 7. Down here we have 7 times 2 minus 3 equals 11. 14 minus 3 equals 11. So these do check out. Here we have, we're going to use elimination, but if you look, we do not have a coefficient that is alike. We're going to have to multiply the top one, looking at this being just a y, that's the easiest one to go for. I'm going to multiply it by -2, and we're going to add. I'm going to put this right underneath this one. -2 times 2x is -4x. -2 times y is -2y, or plus -2y. -2 times 23 is -46. Okay, now we have opposite signs on the 2's, so we're going to add. 3x plus -4x is -x. 2y plus -2y is 0, we got rid of y. 37 plus -46 is -9. We want positives on the x, so we change the sign. X is 9. Go back to one of the originals. I'm going to use the top one, putting in 9 for x to find y. Subtract 18, y is 5. So we get 9 and 5. Let's check those up here. So 2 times 9 plus 5, does that equal 23? Yes, 18 plus 5 equals 23. On the bottom one, 3 times 9 plus 2 times 5, does that equal 20 or 37? Yes, because this is 27 plus 10. So they both check out. Next, we did some story problems, and at a school pool party, Mr. Lewis bought 1 adult ticket and 2 children's tickets for $10. Mrs. Vroom bought 2 adult tickets and 3 child tickets for $17. The following system can be used to represent the situation where X is the number of adult tickets and Y is the number of child tickets. Determine the best method to solve the system of equations, then solve the system. Okay, so I'm looking at these two, and because X is by itself, we could multiply the top by 2 or -2 and use elimination, or we could set this equal to X and solve for, and substitute that in for X to find Y. Let's just go ahead and multiply by -2 on the top. I'm going to put this below. So -2x minus 4y equals -20. The 2 and the 2 want the opposite signs. Opposite we add. We got rid of the x's. 3y plus -4y is -y. 17 plus -20 is -3. We want a positive y, so we change the signs. Put that back into one of the originals. I'm going to use the top. X plus 2 times 3, putting in 3 for y, equals 10. Subtract 6. So we get 4, 3, xy. So adult ticket is $4 and child ticket is $3. And the last thing we talked about was solving systems of inequalities. For that, we're going to graph. We can only graph for this type. And you need it in slope-intercept form, which we have. So the first one, we go to +2 on the y. The slope is 2, so I'm going to go up 2 into the right one. And then draw a line. This one, I'm going to go to -3. I'm going to use a different color. -3. And then we're going to go, it's -3, the slope is -1, so we're going to go down 1 into the right one. Down 1 into the right one. And then connect those. So now we have to shade. To shade, we're going to put in zeros. Let's do the green one first. 0 is greater than or equal to -3. That's true. So we're going to shade the 0, 0 side. For the red, 0 is less than 2. That's also true. So we're going to shade the 0, 0 side. And the answer is where they cross over, where they overlap on the colors. So any point in that purple part would be a solution to this system of inequalities.